Hey everybody, this is Larry. This is day 3 of the Leetcode Daily Challenge. Hit the like button, in March, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Is that real code? Oh, it is just me being lazy. Okay, that's me from the past, I guess. When did I even do that? November 9th, 2022? Is that only like 4 months ago, right? What was I doing? Maybe I don't remember what the situation was. But anyway, let's take a look at today's problem. And of course, you can do the dot find, but because usually those are kind of optimized for stuff like that. So, but let's think about how we want to do it. So, oh yeah, I guess past Larry really was going to talk about what I was already going to talk about. There's Baltimore. There's what's the other one? KMP, which is KMP was Knuth. Who is KMP? Oh, I forget Morris Pratt. That's right, Morris Pratt. There really is like a lot of string finding algos, where they call it, finding a needle in a haystack, right? Ideally, and you would have to, because 10 to the 4th, if you do a naive 10 to the 4th square, that's going to be 10 to the 8th, which is too slow for most reasonable people. And especially since there is a linear time solution. And in fact, the linear time solution allow you to get all occurrences, right? In this case, for example, you find it like twice, and it'll give you both times and not just the first time. I think the one that I usually like to do is Rabin-Karp. It's the one that comes up how do I say it? It comes, string this idea, not necessarily just string, finding haystack in a needle, or the other way around, needle in a haystack. So this is obviously by itself a string finding thing, right? But you can also imagine that, okay, well, when we have a string, what is that? What is a string, right? A string is a character array, in a sense. So what that means is that you have an array of character, and in those characters, let's just say for now, maybe you have the alphabet, you have spaces. Let's just do alphabet and space, right? So now your alphabet is size of like 27, which is 26 plus 1 for the space, or something like that. Maybe you want to times it by 2, 53, because you have uppercase as well, or something like that, right? So that's the size of the alphabet. My point is that now you have some size of the alphabet that but then another thing that you commonly see in competitive programming and maybe even interviews is this idea of finding some subarray that equals to each other, and that subarray contains maybe numbers instead. And in that case, the alphabet may be bigger, but the idea is still the same. And so it's good to know at least one or two of these algorithms, because it does come in play a lot, and they don't ask it in a way such as that is not as obvious as this, where this is the only thing, right? Usually they ask it in a way where the string finding, the needling is part of the problem, and you have to kind of know an algorithm, otherwise you're not solving it. You can't, there's no library for it per se, right? Anyway, so that's basically the context behind it. The one that I like to do is Rabin-Karp, because I think it is just in theory the simplest for me. And the funny thing is that I've practiced it enough times in recent year or two, just because it comes up on Leetcode contest frequently enough, say, right? Not super frequently, but frequently enough that I kind of remember. But if you are able to find it, I don't even know where that would be now, but it's on YouTube. The first time that I needed to use the algorithm, you could see that I could prove it from scratch, because the first principle, and I missed a P in black, but because the first principle is just that it turns into a sliding window algorithm, a little bit of a probabilistic, and we could talk about spaces and false positives and stuff like this all day, and also constructing test cases that proves it wrong. Yeah, but and there are ways around it in theory, but or at least makes it harder to construct without randomized things. And you could maybe do a few randomized things if you really want to, but by the end of the day, like, false positive is going to happen because it is a probabilistic algorithm, right? So yeah. Anyway, so I'm going to go over, I don't know that I'm going over Rabin-Karp, but I'm going to go over my interpretation of Rabin-Karp, and so it may not be as perfect as it, and I hope that, yeah, you don't, don't hold me accountable for it. But yeah, okay. Yeah, let's get that going. So basically the idea behind Rabin-Karp for me is just turning a substring into a base. It doesn't have to be, it just has to be into a big number of base where the base is some number that's bigger than alphabet, right? The size of the alphabet. I mean, it doesn't have to be, but I guess technically, strictly, I mean, but having that means that there'll be less chances for collusion, at least within the smaller space or something, right? So basically, for example, and this is me, like, honestly, I wouldn't say I'm proving it from first principles, but me kind of re-deriving it. So everything you see is how I think about it in my head, from just that idea of big int and sliding window. So everything, I can come up with, right? So basically, for idea, for example, maybe, you have sad, right? So sad, let's just say, we have only lowercase English letters. So let's just say this is a base 26 number, right? I like to use base 27 because zeros, so that you can handle, or like I like to do base of the size of the alphabet plus 1, so that you don't have to handle like zeros and stuff like this. There's an implicit like length type thing in there, kind of. But basically the idea is that this is just, another way of saying it is this times, and you could do it in either direction, but this is just, you go to 27 to the power of 2 plus a times 27 plus d itself, right? And this is basically treating it as a base 27 number. I don't know what s is. Let me see, alphabet table maybe. Alphabet table did not return what I was hoping for, but this is useless. This Google. All right, so 5, 20, 23 maybe? I don't know, maybe I'm off by 1, but basically S is the 23rd characters maybe. So yeah, and A is the first and D is 4, right? Something like that. So then now you have this number that it hashes to, and then you basically now, so that's, that's the needle part, right? And then in the haystack, as we said, after that, it is just sliding windows. So basically, we now calculate the first 3, the hash function, right? And okay, this one didn't match, but let's just say that for a second it doesn't, right? So that we can do it. And then if it doesn't match, then now we slide to the right? And a core part of sliding windows is just try to figure out how to calculate the delta in all of one time, or roughly all of one time, right? And of course, now this, you could just think about it as a number where now, so you go from that to ADB, right? And of course, this is just, you go to some like D times, again, 27 plus A times 27 right, plus D, and then now you have A times 20, oh, this is wrong, wow, sorry, right, plus D times 27 plus B, right? So you can kind of see the pattern of like, oh, this is just, we subtract this part, and then we shift it, this part by multiplying everything by 27, and then you add the B. And then just keep on doing it. So that's basically how I would rederive Rabin-Karp from first principles. Yeah, that's basically the idea, really. So now we can get implementing, right? So implementing is a little bit tricky, but that's okay. Base, we say, is 27. And then now we have, oh yeah, so the other big part about this is that, well, for three letters in the needle, it's fine, right? This is a small number. But if needle is, say, 10 to the 4th, then now you have 27 to 10 to the 4th, right? Or something like this. That's a really big number, right? Let me put the parens in the right place, right? So the idea behind and of course, actually, just to be clear, if you don't do anything else, this will not have any false positives, because that's just how the math works, right? Why would you have a false positive? Nothing maps to the same space. But what makes it a probabilistic one, and also knowing that this is really big, so every time you shift, this is really expensive because you multiply a really large number by 27, it's going to be pretty big, right? Because the number of digits here is, I don't know, a lot, right? Let's just say even it's 10 to the 10 to the 4th, that's 10 to the 4th number of digits, right? And this is even bigger than that. So yeah, you can kind of do the math that way. But so the idea here is that now you have a big prime, right? And what I like to do, because I'm lazy and I don't really do on-site contests anymore, is that I just search for a big prime. So I do like a 20-digit prime, and then I literally Google a 20-digit prime, and then I just randomly pick one of this number, and I don't even know. And there are other things you can do if you know your hashing strategies with respect to hash tables. A lot of those apply as well, like double hashing, chain hashing, stuff like that. You could use 2 primes, for example. Though in theory, it doesn't. If you use a longer prime, you get the same idea. Again, the challenge is not really the test cases. The challenge is other people may be challenging your code, right? Because they know the mathematics behind it. So it's very, I wouldn't say easy, but it is not hard to come up with a counter case. But for the most people, and that's fine. And there are other things you can do to handle it. I'm not going to talk about that because that's way beyond scope. So yeah. So anyway, so let's hash the needle, right? So yeah, needle hash is equal to 0. So yeah, for C in needle, I don't know. So needle hash, we times it by base, right? And then needle hash, we add it to order of. I like to kind of write it this way, but you don't have to. Basically, get the whatchamacallit, like the order of the number, and then yeah. And again, I don't like using zeros just because of some stuff. Oh, and of course, after every one, we mod it by p. So now we have the needle hash, and then now again we just do sliding window, right? So let's just say m is equal to length of needle, and n is equal to length of length of haystack, and then yeah. And then the current, and this is also called rowing hash for that reason, because you have a hash and you're rowing it. I'm going to do some optimization in a second if you know where I'm going, but for now I'm just going to write something like rowing hash. We shift, we add the new thing, right? Haystack of I. And then kind of, right? Not quite yet. So what happens is that we have to get rid of, well, this one is actually a 2. But as we see, because we only care about ones of the size of length that is the same as the needle, this has to roll off so that you don't compare the D that keeps on. So we have to subtract that, right? So rowing hash minus basically same thing here, right? Except for now is I minus m, because that's the character that got rolled off. Of course, we should add a if I minus m is greater than 0, so that yeah, and then but it's this times base to the power of the length, so like m minus 1, right? Something like this, right? I know. I know what. Let me explain it. I mean, I know that this isn't quite the final product. In case you're wondering at home. No. So yeah. And then, but before that, we'll just say if I minus So if I plus 1 is less than m, I think. Oh, no, it's greater than equal to m. That means that the hash has m characters or more. So then now we can say n rolling hash is equal to needle hash. Then we return I. Now we return the first character. I is the last character processed. So it's actually I minus m. Or minus m plus 1. One of those. We'll play around with this. This one's easy to kind of test, right? So that's fine. I'm gonna run it. I know that this may be running okay, but right, plus 1. I knew it was plus 1. Yeah, but yeah. So this looks good, right? But of course, now the thing is that the two things, right? One is this thing is really expensive. Like we said, if m is like a lot of digits, or if m is 10 to the 4th, then this thing is just enormous. So we can actually pre-hash this as well. Yeah, and then also pre-mod it, because I'm not going to get into it, but you know, multiplication is what is the term? Something under the hash space, the mod space rather. Is commutative? No, that's not the one. I'm blanking. But yeah. But anyway, so let's say maybe bm is equal to pow of b to the m minus 1, with the third thing being p, right? That's the mod. In Python you can do this, and if you can't do it, just do a for loop. It just multiply things out, right? So that's fine. Yeah. So this would actually still be kind of a big number, but that's fine. It's only 27 times big number. Let's see if it works. Okay, so that looks good. Let's give it a submit. Oh no. How did that happen? Maybe this is wrong. I plus 1. Okay. I mean, that's weird. I probably messed something up. It's been a while. I always mess something up. Oh no, it went away. Okay, I mean, what was the one? That's pretty sad. Oh, I guess I was gonna say that's sad that last time I got it first time, but I kind of got it like, I don't know if I would count that. I was just lazy. Why? So the subtraction is, did I mess up on the subtraction? So 8, and then it's probably right. This doesn't look like it's subtracting it, is it? I mean, it doesn't, yeah. Did I mess up? Is it m minus 1 or m? Maybe I messed that up. Yeah, okay. Why did I have m minus 1? I actually forgot. And the case, because here, this is query. Oh, Oh, I'm dumb. Actually, I probably know this, but then sometimes when I explain it, like and then I confuse myself, because I actually probably excuses. But yeah, but the thing is that I did it in the other order. That's why. You could, if you have done it before the rolling order, I think then this would have been okay. But I think I just confused myself. But that's good, because now we can see how Larry debugs, right? People like that at home. But the idea is that I actually, because I shift first and then added, what I actually did was, because my visualization didn't match what I was doing, so I had this as my last step, and then I had to subtract this, and this has the component 3. But I was looking at this one, so that's component of 1 less. That's why. Hopefully that's enough. So let's give it a submit. Yep. Oops. Whoopsie daisies. 1067. But yeah, like we said, this is going to be linear time. And actually, oh wow, I kept the print statement in there. Well, that actually is a lot. What is the timing on that? That doesn't surprise me. But let's give it Slightly faster. Not that much faster, but like 40% faster. But yeah, this is linear time, linear time, constant space, and that's really one of the power of rolling hash over some of these other things, is that it allows you to do in constant space, kind of, depending on how you want to define it. So yeah, so that's, if you look at everything, there's only constant space, and we also only have, and by linear, I also mean n plus m, because that's the size of the input. You have to look at the input, that's the low bound, right? Yeah. Anyway, that's all I have for today. So let me know what you think. Hopefully you find this helpful. If not, send it to your enemies, and then tell them that, haha, you will enjoy this. Anyway, but that's all I have though. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.